Alright, hello everyone. This is Sean O'Hare and my partner Kyle Feller, and we are going to talk to you today about a little function and a little coding assignment that we had to work on. So, getting right into it, problem 1 says write a function called Bayes that computes the probability of B given A, provided that the values of probability of B, probability of A given B, probability of B naught, and probability of A given B naught are given. So here's some inputs. We have probability of B, A given B, B naught, A given B naught, and we are to output probability of B given A. So this is how I set it up. We have obviously the function definition with the 4 inputs. We have the code beginning here. So it sets probability of B given A to this big long math statement. And this big long math statement basically says probability of A given B multiplied by the probability of B. That quantity is divided by the quantity probability of A given B multiplied by the probability of B. That quantity is added with probability of A given B naught, which is multiplied by the probability of B naught. That is all in the denominator. So once that runs with all your given inputs, it will be set to probability of B given A, and this return statement simply outputs probability of B given A. If your Bayes theorem function is working properly, you should get these outputs. So what we're going to do now is do some testing. So we're going to take these inputs and copy and paste. And then we're going to take the second one. Whoops, I missed it there. Copy, paste. So we run the first one and it should output 0 point that. So save and run the definition of Bayes theorem first to get it initialized, so it's in the Python code. Then we run it and it runs and it outputs 0.33333. Run the second one and we get 0.680733944 repeating, which is the correct answer. So alright, now we're going to move on to the next function.
Hi, this is Kyle, and I'm showing you the expected value function. So what it does, it's taking the list of outcomes and a list of probabilities. So it's going to run an if function and see if the sum is equal to 1. By doing so, it's going to, the for loop within that, it's going to run through every element, which then EV plus or equals outcomes times probability to see if it will equal 1. If not, it will return a false statement. So as shown for this example here, when running, it will come out to 3.5, since the sum of these are equal to 1. And it will do the same for these two as well. So here, I'll show you. Yet for the last one, it will not, because it's not equal to 1, so it will return a false, as shown right here.
Alright, so this generated grid function takes in 2 inputs. It has prob, which is the probability that a 1 will show up, and square number, which is the number of squares in each row and column. Since it is a square, it will have the same number of row and column. So basically this function generates a grid as a list, and then each item in the list will either be a 0 or a 1 based on a random probability. That's what this if statement does down here. It takes a random decimal value, and if it is less than or equal to the probability, input a 1 in that specific square. And then obviously the return statement, it will return the entire grid list.
Back again with the draw barrier function. So what the draw barrier function will do is it will draw a barrier when a cell number is equal to 1. So what it's doing is a for loop within a for loop. So it will take row, it will go through row once, and then it will go all the way through column. And it will see if grid is equal to 1, which the cell is equal to 1, it will draw a barrier there. So that's what the pygame.draw.rect will do. It will actually draw the physical barrier there of the cell.
Alright, it's me again. So we have this method called getCell. It takes in the grid size, takes also in the number of cells in each row and column. It also takes in the current X and Y position of you, the player. So this function starts out by doing a little calculation to find the size of each square. It takes grid size and divides it by the number of cells. Then it sets row and column to the according Y and X position divided by the square size. So for row, it's Y position divided by square size set to an integer, and for column, it's X position of the player divided by square size parsed to an integer. It then returns both.
Back again with the corner points function. So what this is doing, it's trying to find the coordinates of each corner point of a cell. So what this will do is it will take the M, which is the length and width of the game window, the cell number, which is the number of cells in each row and column, the X position of the player, and the Y position of the player. So what it's going to do is square size is equal to the length and width divided by the cell number, which is also going to run through the top left, top right, bottom left, and bottom right, and then it will return it later on to show where the exact coordinate points of the player is, which is what it's trying to return is a 4 tuple.
Alright, so the last function we have is defined as move. It takes in the current position of the player in X and Y, takes in the distance moved, takes in the list grid, takes in grid size and square size. First, it checks for key events left, right, up, and down. And within those, it has an if check that checks for if the position is greater than 0, if the rightmost position of the player is less than grid size, and then if the Y position is less than 0 for the top, and if the Y position plus grid size is less than grid size. Then for each individual section of grid, being the topmost left corner, the bottommost left corner checks for if the grid space is equal to 0. If it's equivalent to 0, then you can move through that space using the decrement distance by X position. For rightmost key presses, it checks the top right corner, which is this first grid element, and the bottommost right corner, which is this grid element, checks for collisions there. And for up, it does the same thing with the equivalency statement to 0 with the top right corner. And also with up, it also has to check the top left corner for a collision. For key press down events, it checks bottom right and bottom left corners appropriately. This function then returns the new X and Y position. So if we run this function real quick, we move down to the right, and we can't move to the right. But we can still move down, 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 down to the right. I cannot move up, but I can move to the left. So I can now move up. I cannot move off the grid. Okay. Just another real quick test for you guys. I will get myself stuck. Cannot move to the right, cannot move down, cannot move to the left, can move up. Then I'll just navigate over to the edge. Down here. Can't move off the edge, can't move to the left. I can move down once I hit the bottom corner. No moving to the left, no moving down, no moving to the right. And so, sweet. Thanks, guys. See you later.